Okay, so welcome back from the lunch to the second part of the session, Materials Quality and Maintenance. I have the honor to be the host on that part of the session because I'm actually also the first speaker. I like to introduce the new IOF group for Material Science and Engineering. And I will just step in. So if I'm lucky, you should see my presentation. And if that is true, you will also see there are two names on the first slide. That is Alexandro Tudor and me. We will, first of all, at the start of the group, will share the chair of the group. Alexandro can introduce himself because he actually has a talk right after this one. So I will shortly maybe introduce myself because I'm pretty sure you don't know me. I'm Thomas Hanke. I'm a researcher at the Fraunhofer Association in Germany for about 14 years now. And from my background, I'm a material scientist and was pretty from the start starting also to do some data science because actually nobody really wants to repeat all the tasks again over and over. And this was my first experience. And 4 years now, I'm doing ontology work, let's say, from the bottom up. And I'm also coordinator in a joint venture between the Fraunhofer Group Materials, which is 12 institutes of the Fraunhofer Institution, and also the Bundesanstalt für Materialprüfung und Forschung in Berlin, which is actually that institute which provides reference data for materials for the industry ordered by the government. And we are approaching the IOF now with that group because we actually think there is a need, especially for the domain of material science, to be addressed. And that presentation will be about this. So I would like to summarize, first of all, why we actually do this. In material science, we have rich context. You might also all know this. We have a lot of methods. We have industrial processes and standards all over the place, which are necessary to provide comparability of data, quality, and so on. But there's also a lot of initial knowledge necessary to understand actually the data we have. And this is common in our domain, and nobody's actually talking about this very much. So you exhibit those problems normally if you step into a subdomain, even as a material scientist like I am one. You step into a subdomain and you don't even speak the same language as those people. You have to confirm actually on terms if they are saying the same thing. And I was also in standardization efforts, and this might take years. So we also heard from Melinda in the morning that even confirming those terms and working on that is an effort which may take years. And that is from the history also true for standards, which is they have a kind of overlap with building ontologies. And there's also bad traceability because most of the shared data in our domain is actually aggregated and treated by algorithms and then published only in publications, and you don't have actually access to the original data. And even to make it worse, there is a lot of natural language there, which, as I just told you, is also not used in the same kind of way, even in standards. So even in standards, there are terms which change from standard to standard, which are not really agreed in the domain. What we already learned from our work before, so I'm working in different digitalization efforts in the material science domain. like the platform Material Digital. We have the national research infrastructure initiatives and so on. And what we learned is that our material data significantly increase in value if we actually just document it better. And that might sound trivial, but actually the people are not doing this because they don't see value in this. Because the whole research work is actually only valued by publications at all, or mostly. To do this, we have to actually semantically represent every method which leads to some data. And that is really a problematic thing because we not only have those standards around, which are a lot, and they are all in place and used. There is as I know from Fraunhofer Institution work, there we are very near to industry. We change methods according to the problem at hand, and so they are adopted a lot. And if you know what actually is going on with the data, you know that it's not easy to compare it if the documentation is not on a very high level. So normally researchers tend to neglect data which is at hand because they don't know enough about it, if it's comparable or not. The methods are so diverse that I always say, so in the Fraunhofer Association, there are about 20,000 researchers, and I would say every one of them has 3 individual methods. So there's actually no option for an ontology expert or for ontology experts to do all the work and create ontologies for those methods. It would take not only years, it would take centuries to do so because there are not enough out there. We already heard that before in the morning. So there must be another way to do it. We can't wait for this efforts. And that's why we want to make people actually create their knowledge graphs by themselves. And that requires a new set of tools, which is actually not available. We already know that ontologies should not be built from scratch, even if that is a common thing to actually start learning on what ontologies do and how to develop them. But actually, in that case, it doesn't make sense because interoperability levels only rise if you actually reuse a lot of ontologies out there. And in the best case, ontologies well maintained and with a strong and big community. And the last thing we learned is that we have really trust issues with working with the industry. They don't want to share the data, and they have a strong need for sovereignty to their data, and they want to be all in charge on how that is shared. So the actually result from this discussion is to have decentralized data spaces where they can share by policies and they own the data all the time and can regulate on this. So I was trying to put down a charter, which is first of all a first draft, yes, we want to build a reference ontology. This is true for I think all the groups in the IOF because we want to build reference ontology stack, and that is maybe an addition, and that is for sure also true. That's why we are meeting. We want to be a contact and interaction point for ontology developers to integrate their content into our subdomain if they fit to the material science and engineering domain. And then we may make sure that we fit into the IO of ontology namespace. Our main objectives is that we want to make data shareable between research institutes, engineering services, and manufacturing industry. So that is a more strict or specific area we are working on. So this is mostly about materials, material characterization data, and so on. That should be even also the quality assessment of products and materials involved. That's these kind of things. We need a participation workflow for new terms and guidelines on data modeling. The participation workflow is already covered by the IOF. It's written down in the technical principles, I think. And but we further need that modeling and graph creation guidelines for non-ontology expert to create their contents in accordance to our mid-level and domain ontology in the end. We want to provide interaction consulting for those people, and also in, let's say, in the future, see that we can actually do this for certification bodies. So from my point of view, to create graphs for standards and to maintain them with more automatic methods and see if they are valid and can be reasoned, that should be a major goal. Because from my experience, this day standardization is way too slow to cover the rapid developments of new materials and methods needed for their characterization. So this is, I worked in 2 groups for standardization in my life, and this is not a possibility to be fast if you discuss these in those small groups of people, and even if they are very good and determined, this is not fast enough. Okay, and we of course connect to all the groups which try to do the same or similar goals. This comes naturally. Okay, we have some premises. I think I have to speed up because I will be way over time already. We will use the IOF ontology stack. This includes BFO 2020 as a top level. We have the technical principles which you should apply. And we will try to provide also alignment strategies for other relevant ontologies. That is maybe very interesting for the OntoCommons people in the room. I was telling you something about the method knowledge graphs already, and we have to provide a way they can do it. This is the networking slide. I will just don't go through all the points because short of time, so there are a lot of logos on there. And that is or many people which will join that group or already committed to it are from those efforts or projects, partners, and that will come in handy. Okay, we have a starting point, which is an build MS ontology for the material science engineering background or domain. And that is actually actively used by the joint venture between Fraunhofer Materials and Bundesanstalt für Materialprüfung und Forschung. And that is also used in other projects in the surroundings of the Platform Material Digital, which is a national platform project. That features already a lot of things, and what is based on is actually Common Core Ontology Stack. So that is quite near to that what we already got or what I've seen in the IOF core ontology. And the next step would be to migrate all those terms we defined there to the IOF core ontology. I really hope that will work out easy. So, and this is the end of the first talk. So if you want to join, you can for sure use the official request through the Industrial Ontology Foundation participation request. And there are also the direct contacts here, and the QR code stands for my LinkedIn account, which you can also get on if you're online and you click on me as a speaker in the profile, there should be a link. So this is for the first part, the first talk. So thanks for your attention. If there are any questions, I've been willing to answer them, honestly.
Can I ask a question? Can you hear? Can you hear us?
Yeah, I can hear you.
Okay. It's Gerhard Goldbeck from the Auto Province and EMMC and so on. I mean, this is a great initiative, and we have interacted. I was just wondering, obviously you probably weren't in the sessions yesterday. You know that we did a lot of investigations around, which ontologies are from the axiomatically suitable for material science, and there are some issues with BFO as a top-level ontology. What is your view on IOF at the moment, using BFO as the only top-level ontology framework, which makes the collaboration within such a working group really difficult if other ontological choices are excluded by design, by choice or by decision or whatever you want to call it? Because there are things such as, the glaring example is that every material object has to have a rest mass, which means you cannot represent fields in BFO at all. There are all very, let's say, very difficult. There are questions around, how you describe. There is the question: is a 3D ontology really suitable for material science when you have all of these changes going on? And all of these, different answers can be given by different people, but it's certainly the case that there are, the question why this has to be exclusive to one top level.
Actually, I think it's you have to make the decisions on that. So if you don't decide, you cannot move on. This is the first very general thing. So if that is the right decision or not, most of the time depends on what is your goal and what you neglect for this. And I would say the BFO 2020 has its advantages because it is the one actually covered by a standard, which is a good thing. And I know these disadvantages or cons you were pointing out, but actually they can be dealt with. Even if it might not be that comfortable to do, you have to wait that out with the advantage to actually be part of an even bigger community. So you can try to fix these things, but then you neglect actually the interoperability the BFO 2020 might offer, and that is a hard decision. So, and if for my let's say out of my perspective, the material or the physics part in material science is only a part, and it is for some people the most necessary part and the biggest part. But if the more you approach the engineering scope, it actually isn't. There come other things into play, like logistics, like quality assurance, how processes interact, and what effects they are doing, and this in a, let's say, more, you have to reach out to the engineering view. So how the engineer is actually dealing with these things, and that is, you have to find the right approach. And for myself,
I know that, but I mean, there's also the fact that if you hear from, for example, the Siemens presentation on the first day, that they are currently using ISO 15926. So again, not BFO. They are open to top-level ontologies. So it's really also the issue is not that you have to make choices, but it seems like if you want to build a community around industrial ontologies or make already a choice for everyone in the community that only this top level can be used, then this is a serious limitation. That's all I'm saying.
That might be true, but the benefit of joining a greater community and to accelerate our work, that we actually get rid of those big problems in our domain, like doing research over and over again, because we actually can tackle the knowledge, is worth it. Okay. For sure, that's just my very personal view, you know.
Yeah, I don't want to hop all the time.
I understand your concern by and yes, I have a question. You are currently in the way to create the group, or is it already working quite well as identified? So what is so the maturity, not of the problem, but of your action?
We need a proper kickoff. So we have many interested people, and it was difficult to start this group because of personal affairs and also the vacation time. You know, it's season for for vacation. People are actually not present, and that's why actually a good starting point is right after that workshop.
Okay. And a question that you maybe not mentioned. When you speak of material, what kind of material is it? Typically, you solid, liquid, a composite, a group of composite. So, what is typically what you are on, or you intend to handle?
Actually, is everything which can be covered under the material characterization. So, what a material scientist is doing, that covers all solid states, all states of matter. So, everything. What it might be a better category would be everything that is relevant in a technology product. Let's say everything which has a function in an engineering way.
Okay.
Is it legit?
This is part of the definition in an ontology, but it's clear. And for example, just to understand, a raw material like sand, for example, which is of course itself is complex, but let us simplify. Is it part of a material for you?
Yes.
Yes.
Everything. So in the life cycle of a technology project, if you want to do a life cycle assessment, we have to use everything which is used to construct the product, even what is actually used to build it as a utility, and also everything which it decomposes anymore and recycled and might enter a life cycle again. So yeah, everything that is actually handled by some kind of industry will be a material.
Yes. Okay. And to still to go in details, on the biological tissue is a material, or you are limited in organic or not?
No, I would not limit it to inorganic things or taken from life forms or something. Materials, everything uh, which is aiming or which is used in some kind of technical process in the end.
Okay.
Okay, I think I'm pretty sure I'm way over time already. Maybe we have to move on. The next talk would be from my dear colleague Alexandru Tudor, and I think you can introduce yourself way better than I do, right? So I would say, please share your screen, Alexandru. Are you there?
It seems he's not.
Yeah, this is no good. Okay, but in that case, I will just do my second talk and pull that into that place here. So maybe there will be more or less a few things more clear in the end. So okay, I have a second talk, which is about the tool chain we were building, and like to introduce also to the IOF. And that centers kind of around those things I already told you with those knowledge graphs. So um, we have that problem that there are not enough ontology experts out there. I'm not an ontology expert, I would say. But I can apply ontology terms to build graphs which express actual knowledge about the method. And also, other people can do this if they actually have the tools and guidelines to do so. So there's no need to have years of experience to build something actually expressing knowledge. Okay, so the premises is again that the method graphs should be built by domain experts, and we need a tool for to transform data which utilizes that knowledge about methods in a very automated way. The components of that tool chain should be non-monolithic because I'm pretty sure that there are, or you all know this, that there are a lot of formats of input data out there, and creating metadata for them and mapping them to something else is a diverse problem. So we have to break things down, and those things should not be done in a monolithic application. If we can break things down and document them well and create a tool chain of microservices, this is the modern way to do it. If you are therefore very clever and try to do it agnostic to ontologies in a, let's say, the best way we can, then it will reach out for a greater community. So as Gerald Gottbeck already told us, the choice on a top-level ontology, and if you build tools just for this, also limits you very much. So maybe we can get around this. We will see. We have to reuse vocabularies for data resources, which are a lot of already given by the W3C. And that is also true for exchange formats. So if we have components in the tool chain which actually push data from one endpoint to the next one, there should be exchange or good exchange formats which are known to the community or the, let's say, the people actually working in the semantic. And the whole tools must be documented well, for sure, because if you don't do it, nobody will use them or participate in the development. And what we did, and I hope actually you can see that because the picture is quite small, is to outline a tool chain which works already. And not in every component. So there are different maturity levels of those applications. But you up here you see the tool chain, or in the upper toolbox you see the tools we created. And I would try to pick out one of those pipelines you can build. And this is maybe in the material science and engineering domain most necessary pipeline for CSV files. And CSV files are problematic because they come in whatever shape and whatever content, and they are not standardized at all. But that is 90% of the data I think we have. So there is a tool out there, CSV to CSVW, which utilizes the vocabulary of the W3C to create metadata for those files and do that in a very automatic way with nearly no user input at all. And if you have that metadata, which is actually should located at the raw data, then we can try to create a mapping between knowledge graphs we created for that method, actually a graph which just shows how that experiment is conducted. So if you have some kind of tensor test experiment, there will be all measurements documented which are done preceding actually pulling that specimen apart and measuring the force and way actually needed for this. And this is all in the graph, and then we map those two together and create a joint data set, which then can even be checked with shackle shapes or be measured by other means. You can run a reasoner through this tiny data set with governing ontologies, and that thing is then ready to be digested by a triple store, where you can actually do the additional reasoning steps between data sets. So this is the idea. Oh, is it? Yeah. Okay. And the first thing is actually to annotate the raw data. That tool, I've posted the links in here. So what it does on the left side is the raw data. On the right side is the metadata created. This is a JSON LD file in as a result, and you see there up there in the context are the prefixes and the used ontologies, and then actually the whole additional header, which is very common in such measurements, is transformed into annotations, and there's also a part in the here which actually enables you to read the whole file. So in the dialect section, you will find the delimiter, the rows to skip, which are the additional header, the encoding of the file, and also the whole table schema we were having there. So with that file, you can actually read the raw data. In that file, there is no data point, so or there is no time series data included. It is possible to include this, but we decided not to do it because actually, if you are able to read the raw data file, you don't have to duplicate the data, right? And the next thing is actually creating a mapping. And the mapping procedure should be as easy as possible. And because it must be conducted by the domain expert again. You have seen maybe in the slide before that there are some very uncommon terms for data scientists. So what actually is a German term aktuelle Probe? Could be anything. So this could be some kind of part of a measurement device. It could be the specimen ID, whatever. So the actual person knowing this is a domain expert conducting this experiment because he named those things, right? So he is the only one who can create the mapping, and that's why we make him do this by selecting the method graph in the best way. He did that by himself. And then the only thing he has to do is pick with a dropdown information bearing entity, which are the entities in the metadata created for the raw data, and an information content entity, which is an entity in the method graph, explaining what that is for. So a measurement, an identifier, or something like this. So, for example, there would be a specimen identifier aktuelle Probe, and he could just map them together. And the result of this is a mapping file. We used YAML mapping files because they are more human readable than RML files. Everybody ever seen such an RML file will actually know this. But in the YAML files, you can actually see those expressed rules, like from the source, iterate over all the data nodes and columns. And if the condition for an entity there is met, that the label is actually of string datum, then this is experiment date. And if you put that together, you're even able to aggregate those rules, so and test them on files you don't know. We can just run a mapping and see if all the rules are applied or if there are many rules applied, and just calculate how good is that mapping suitable for that data, and that makes it automatable. So you can even test a lot of mapping files on unknown data and see where you get it, if that fits the method. So you can even find out. Okay. I was saying that already. This is a link to the people of RML.io publishing that, and there's also a tool where you can try those things out. It's called Meti. Okay, so actually the only thing we need onwards is then this mapping file, because the input and outputs are pointed out. So the method graph is pointed out, and also the metadata, which I like to map, is pointed out, and all the rules necessary. So the output of the running that mapping is the triples combining information content entities with information bearing entities, and then we have a data set. And what we can do additionally is to apply shackle shapes to test those things. So if for an engineer it is important that actually for every device measuring something in there, there should be an identifier, because measurement devices must be identified and they all should be calibrated when that measurement was conducted. And that can be done with those shapes, right? And if we done this, we can output to the user what is actually problematic in the data or what he could enhance. And when we did this, he can actually increase the quality, or he can let that data be as it is, and then we know at least about the quality, and it is ready to be digested by TripleStorm. So this is a slide trying to show how actually that graphs are built. So the domain expert is actually using Draw.io, which predefined structures which represent individuals, and then you can just build a graph together which makes sense for this method, and put it on a web resource where we can actually access this by URI. And we also provide already a guideline which is very much experimental, but it works for some domain experts already out there in other projects. And we also have a one-stop tool, I would say, which is in development of the Bundesanstalt für Materialforschung und Prüfung, which is a plugin to Draw.io, where you can have a lot of additional features like ontology lookup. You can change those boxes very easily to other entities. You can check if actually that visual syntax is legit. And you can even map tabular data to this. So you can just mark an entity and map a column to this on information line in a spreadsheet, and then create your RDF data right away. Yeah, these are the features of them. I just told you this. And there will be publication coming out soon, so there is no preprint. I would have posted the link here, but it's upcoming. So be prepared. And there's also again the slide with the content, my contact, and so on. So if you want to know more about it, just ask me, just contact me. So what are the questions?
No question. There is something that I have not understood in your explanation. You start from a file, either a text file or another kind of file that the instrument delivers. I think, if I have well understood, you have already some patterns to translate those files. but it is not sure that all instrument or apparatus will follow will follow patterns that already exist. Or maybe there's a need to create some other extraction tool. I am right or not?
No, they can build their own pipelines. They create the mapping by themselves. So they have a graph. They can select even a predefined graph. So we have in the GitHub repository already some graphs which are, let's say, try to be in accordance to a standard. So they could pick a graph, change them to according to their needs. So if they do something additional, let's say they are changing a standardized methods by introducing some kind of thermal treatment as a process in between. They can do so, point out the additional information, and create a mapping for their data file.
Okay.
And that is aims to be used by, let's say, some kind of file content management system where you can introduce workflows. So you could imagine there are some components out there like CCAN where you can actually have an event, a new file is dropped in, and then you can just say, oh, okay, this is a CSV file, or this is it a kind of CSV file, and if it is a CSV file, let's create some metadata for this. And the metadata creation tool is just aiming for this, so explaining this file, and it works or works not. And if you have it, you can try out different mappings to create a data set. And if you find a perfect mapping, let's say all the rules are applied in that mapping, and then you can automatically create a data set already. More questions? So I'm way over time, even with one talk less. Maybe Alexandro, are you here?
Yeah, I'm here. I think you can already see me, but
Great.
uh,
So I was just doing the third talk as a second. So if you want to share something, then that is the
yeah,
right.
I can share my presentation. We had some technical problems, so that's why we couldn't go. But I think this way to arrange the talks was even better. Just to make some statements. So our group has been working for years, as you could see from the presentations from Thomas. We have a tool chain. We have gone from multiple ontologies with top level ontologies. First, we just built things on the BFO, then we went further. But I will start with my talk and we can discuss them later on. So let's see if I can get the technical part through and share my screen. Um, okay. So the software I want to present and the website is matportal.org because regardless of top level or mid level ontologies, there are some basic problems with ontologies. Um, First of all, to introduce myself, I'm Alexander Fodor, a computer scientist. I have experience in semantic web for 13 years now. I was one of the org admins for the Wikipedia, main admin for the German Wikipedia chapter, contributed a lot to it, and have a lot of experience building communities around semantic web technologies. And building communities is really important. So this is why we are working really hard on the software, which is a an ontology repository in order to solve some issues that ontologies generally have. Because they're spread out, they're on the web, they're everywhere. It's hard to find them. They have a low availability. They expire. People create them and then they publish them somewhere and they go away. They're overlapping. There are a lot of ontologies for the same thing, maybe because they have a different top level ontology. They're in different structures. Ontologies used to be built even before the semantic web. Even a database structure can become an ontology, but the main problem usually is that they're made for publishing, proving a point, but not actually being used. So they're made in publications, they're in material science especially. They're made for publications. They're very seldomly applied, and they're not like codes. So this main problem that an ontology is like to prove a point, not to build something around it, has been a problem in every domain. In order to address this problem, ontology repositories have popped up. And ontology repositories, especially BioPortal, have proven to be the way to go to transform ontologies into software. As GitHub did for software, BioPortal basically, maybe inspired by SourceForge, um, made ontologies work because it provided single stop place for people to publish, download, browse, search, align ontologies, annotate these ontologies, recommend the best fitting ontologies that are for a domain, and was very successful in supporting the OBO Foundry and the biomedical ontology domain. And here, based on the success, the Ontoportal Alliance popped up, trying to generalize the software, make it applicable to different domains, and take the approach and the steps that BioPortal did for the biomedical domain into different other domains. It's not only the software that the Ontoportal Alliance tries to take further, it's also the approach and how to create a community and how to take this approach towards community-based ontology development further. There is BioPortal, AgroPortal in France, MedPortal in China, EcoPortal in Italy, CipherBar Portal is also in France, and we joined as MapPortal as a full member of the Portal Alliance for material science. Uh, Map Portal offers, first of all, it was really necessary for us in our development. We are developing a lot of different ontologies in Germany, in the Material Digital, in Mapwerk, and FDI. These are way over 100 million euros in development efforts, maybe close to the next number. I'm not really sure here, but and we need to find these ontologies and process them. So the software was really helpful in this. It offers collaborative ontology development platform, version management. You can search for ontologies. You can have automatic mappings between them. Text annotator, advanced REST API, persistent URLs, visualization, and detailed documentation. You can see some screenshots here from the software. You can also go on the portal direct, mapportal.org, and see the different ontologies we have there, or submit some, which would actually help us very much. You can search for concepts, see which ontologies fit to your domain and your specific application. If you don't know which ontologies fit there, just paste in some text into the annotator. It will find the concepts, or we have a recommender where it will see like which of the ontologies covers your domain best based on the concepts that you put in your text. We also have automatic mappings that are generated between ontologies, but you can also submit mappings in a specific format that all of the Autoportal instances use. Um, for future developments, there is a Onto Alliance meetup in September, so in 2 weeks from now, where I will be present. We also have a user panel, so if people from material science want to join the user panel, they're really welcome. We have all of the other portal representatives from around the world and all of the other user panel representatives. You can talk about which features you want or how you wish such a community to develop around an ontology repository. And we're going to be publishing a new version of ModPortal based on the newest code and also introducing some new features that we have been developing, such as GDPR conformant statistics, improved mappings, and of course, you can sign up just to submit your ontologies. You can sign up to our mailing list. You can follow the latest developments on GitHub, or just ask us a question or whatever you want at matportal@maprolab.org. I don't know if we still have time for discussions, but this is something that Thomas needs to say.
Actually, I would say we have time for at least one question, right? Should have. Is there any question? Just speak up. So if that is not the case, we should actually start the panel discussion. I don't know if we have to do anything in that software here.
We can start. If there anyone present with a list.
Okay.
Only online.
Only online. Okay. So yeah, nice. Okay. We should have a few people in the panel here, and I heard already Gerhard Goldbeck.
Yes, I'm here.
Is here. I think many people know you already. You're the EMMC Executive Secretary, and you're also Managing Director of Goldbeck Consulting Limited, which is project partner in a range of EO projects like OntoTrans, OntoCommons, Marketplace, BIM, Oyster, Open Model, and so on. I will try to introduce everybody. If I miss something very important, please don't hesitate to add things. I just try to get back on shuttle. I don't know if Heiner Oberkamp is also listening. I know. No.
Oh, he's not here.
He's not here. So okay.
So
then
I'm not sure whether he really knows that he's in this panel.
He knows because I notified him.
Oh, okay, yeah.
So he also has a questionnaire. So maybe he just not found his way into this session. I don't know. Okay, we have Alexandro Tudor here, which is gratefully introduced himself already. And we have Hank Burkholz. He is information security specialist. And Hank, if I say anything wrong, we know each other already. So, and he's co-chair in the Internet Engineering Task Force for IoT Operations Work Group. He's principal architect and standards engineer, and he's mainly working at the Leibniz Institute in Bremen, right? Right.
That's correct. And maybe I'm audible now. I think it tells me I am. Oh, wonderful. Hi.
Great.
Maybe we're colleagues. Think next.
Normally, there should be also Roy Brooks from Circular here, but as I can see, he also is not in that panel discussion. Okay. Nevertheless, we should start because the time ticks, and I prepared some topic we might like to discuss, and that is actually what are the special necessities of ontologies and related to in our domain the material science and research for and industry. And there are some things which usually should be key issues which should be addressed by applying semantics so that we are actually don't miss the right parts we should address. So I know there are many issues which are addressed by different projects around, but what do you think is the most important issue we should address? So Alexandro is raising his hand already, so please go forward.
Well, the number one issue that I've heard from everyone is documentation. And this has been the guiding factor for all of our choices, Thomas, is that without good documentation, there is no way, especially for industry, uh, to work with ontologies. So the path is set by the available documentation. Ontology, especially through its um, power of modeling, of being very open towards modeling the entire world. So it's your worldview, being very expressive. Also, it's really hard to use. So documentation is the number one thing that even makes it possible to use the technology and to take steps. And of course, industry has these constraints that they need to find people to actually apply things. They need to train people, and we're not really doing it anymore in universities. There is a necessity to use this in industry, but documentation is the number one thing, and training for people, documentation and training. This is at least one of the main concerns that I've always heard over the years.
Okay. Yeah, I strongly agree to this. I would even say there are maybe even more special needs on documentation, which are more should be major or addressed in a major way. I know that Gerhard Goldbeck is doing a lot of work on those topics for years, and because the MO evolved in such a way that actually it deals with a lot of issues which are of more importance than just pointing out what way an object goes. So maybe, Gerhard, you have some things to add to those issues, which in partnership, especially with industry, should be addressed.
Well, I want to also say documentation, but also you're working on this, and there's some good efforts going on the agreement on how we classify things, what do the key terms and terminologies that we use in materials science really mean. Yeah, I mean, we had a question earlier. What you see as a material, right? I think if we're really talking about ontologies, we have to make those very clear. Also, both from two sides. Yeah, from the side of what it means to the domain expert, the subject expert in material science, and also what they really mean in the ontology. I mean, if we want to use ontologies, if we want to use top-level ontologies, we have to provide both sides, at least to start off with this reference layer, right? So that we have some firm basis on 2 feet, on the ground, one on the side of the material science and the other on the side of the ontology. And that needs to be really well documented. And then, we obviously, have been working on, terminologies for classifications in modeling and materials characterization and so on. And there the issue is making sure that bridging this gap, I mean, this is like the standardization work, between all of the different use cases where everyone sees the world in a way to their use case, which is obviously important. But, the issue with interoperability is it's not just solved by saying now we've got an ontology. Somehow you also have to somehow map these different views onto one type of framework. Otherwise, everyone has their own ontology, which also doesn't help. And then the question is, where do you then make the say, okay, this is how far we go, because I think we should only be concerned with these reference and domain levels. I think it's hard to achieve this ultimate interoperability for everything. This can be done by mapping. I mean, you already showed it there, right? So you map, okay, this is how you represent it. Of course, at that point, you have to make a choice. How does that map onto the general framework system? This has to be done by the end user, and they can make that decision. We cannot make it for them. There is, at the moment, the big thing is, I mean, just to pick up what you said earlier, there are ontologies we should reuse. My view is there are, in the last few years, maybe there have been some developments, but in our field of material science, there really are not that many ontologies at all. I mean, at least not ones that pass any sort of standard on documentation, or is it really useful? And so we find that
even if I can just interrupt, that is actually the interesting part. So we have already systems in place which actually deal with interoperability and how data should be represented, right? In engineering, this is very prominent. This is standards all over the place. This is what worked for centuries now, and how to deal with it. This is not only a question of top level ontologies which one to use. It's also on another level where actually the interaction with the certification bodies and standardization bodies should take place. And I, for now, don't really have a clue how that should work. So there will be a lot of representation of standards out there, graphs in different ontologies, and they somehow should fit together, right?
Okay, so
And
then
what
what do you
mechanism?
define as an ontology? I mean, any dictionary or?
No. I really mean what is captured in a standard. So how a test should be conducted, the steps necessary to reproduce, the documentation steps to do, the information to be covered to be comparable. This is a very valuable information we are covering for decades, and that is actually that holds together the very part of engineering science. So if we cannot trust on this and don't have reference data, then we actually are lost. And in this introduction of ontologies and knowledge graphs, that should be covered somehow. And those mechanisms we had earlier, Alexandra, I didn't see your hand, they should have a part in this. And I'm not sure how that is actually should work. So, Alexandra.
So I want to touch up on this topic, and from October I will be working for the German Institute of Standardization, and working on the standard-specific ontology standard. But also in our work here in material science, we have tried to avoid discussing too much on terms and terminology and just following the standards because it's an absolute requirement for the entire industry. The processes that we describe in the ontologies and everything that we do is covered by standards that are quite specific and important to be followed. The terminology and how the terminology should be expressed is also covered either by DIN or by ISO standards. So we always need to follow that. So the anthologies follow those processes, those standards, documentation, and how they should follow. And we model that in a machine readable and interpretable way. So one of our goals is that we cover that standard in a way that the system can interpret it and verify that our data and everything conforms to the standard. At least more in this material characterization, we're not doing any complex drug discovery or new material discovery way.
Yeah,
Um,
yeah, yeah. That is true, but actually, how it is done, Hank, I know that this is actually the point where you should step in because there must be some kind of mechanism where you can certify such graphs, and how that is actually done and who comes into play. That is what concerns me most. So, Hank, sorry.
There's
Yeah,
a
so
question here.
go ahead,
Yes,
go ahead.
yes, I have a comment based on the discussion. Since we are here at the beginning of this Congress, we hear a lot of difficulty. One is addressing the industry, and the other is how to be formal in the right way. And just imagine that you are a worker and that you have to prepare something. Either you take the documentation, you read it, and once you have understood everything, you can go to your machine and correct it. Or you can have at the end a question, what is the problem? By a series of questions, find a method to repair the machine. I am wondering, and this is very pragmatic, not formal, if a kind of assistant that will guide you based on existing ontology or something, guide you and ask you your concept or your word. Is it more like that, more like that? And by doing an assistant, it will suggest you a place, tell you, oh, this exists or this may be that, and helps everybody to position his word in the system, maybe with different concepts and so on. I'm wondering if that exists, because in practice, everything that I heard is you must know the system before being able to do a change among you, because you are maybe not completely true, but if you are from industry and you don't want really or are not able to understand all this formalism, we need an assistant to help you at least to make the first walk. I don't know if that idea was already mentioned among you.
Yeah, if I understand correctly, I mean, for me, this is basically the discussion more regarding. Okay, so what is it? What is the use case, and what is the different cases? What overall is the requirement for that system?
For the requirement.
So if you want to build, I mean, your example is for me. Okay, this is you can of course build a recommendation system for this worker, right? On the other hand, what we're talking now, let's say, is okay. How can I build this system and at the same time make this interconnected with all of the other things from other workers that maybe use a material in that process that other people use also in other, or there is a supply chain, or there is something else. And this is where the difficulty is. It is when you have more like this system of systems, then you need to somehow come to an agreement about these knowing this as the overall thing on overall terms, because otherwise you lose the interoperability. So what we have at the moment is more application focused. What we're aiming for is more overall system.
I would say, if I can add to this, there are several classical ways to deal with this, and this is by example. First of all, so everybody likes to copy, right? So if you just provide a detailed enough guide, uh, people will get it even without additional software. Everybody likes to be assisted, most people. So I think we can deal actually with this. And even if you provide us terms and things that actually people can understand, then we will succeed. The question is, and again back to this, Hank, is how could we deal with representations which should be in a very high standard so that other people should use them and which are as reference to others. And this is even a step further. So my individual method can be good or bad or something. It depends on actually how I calculate how the quality of this is. But if I want to have graphs representing standards with the same importance than the standards actually are, then we need a mechanism actually checking them. And maybe Hank, you have some further things how we can actually.
A lot of thoughts about a lot of things of this, but I'm not cranking all my thoughts into a monologue here now. But I want to start with what Alexandru said initially, and that is documentation. And thank you for the background noise. Documentation is lacking. Why is it missed? There is a benefit to document things because it's visible. Suddenly you get it, and also you can find it. So it's a general issue to discover all the things. You are basically the ontology requirement that comes from some places, the need to be interoperable semantically. That's like a big market with a lot of solutions. It's like the IoT. You have like a lot of solutions. They're basically competing with each other. They're kind of doing the same thing, but aren't. So this is like standard 927, XKCD 927. If you create the 13th standard, it's solved them all. It's just another standard. So that doesn't really work. What would work here, and that is also heard, is to use and reuse vocabularies, terminology, thesauri that already exist to make people identify with the problem. What I've heard, actually, unfortunately, is people try to use top-level domains, mapped everything, lost the engineer, didn't understand anymore, were desperate, and fell back to their own terminology and built an application-specific one that didn't connect anymore. That is happening over and over again in existing projects right now. So that's frustrating because you need more guidance. So what you need is visibility, and I think that's the documentation of terms really comes into place. And I'm actually not talking about ontologies yet. I'm thinking about the legwork of defining this vocabulary and we have this. That's why I think the IO Foundry is one of the places we target, because they have other terms that you don't have to reinvent. They use BFO. Okay, that's abstract, not as abstract as before, but still, not MSE. And so what we need is this identification, self-identification with these terminologies we want to aggregate, make them visible, document them, and then give, as Thomas said, small examples from these lists of words, of vocabularies, dictionaries, and give them an overview how to use process and concept of a machine and material, how to do object representation, material representation. Maybe the material is ephemeral, it doesn't exist, it's in principle. Maybe it's a thing that you produce 1 million times an hour. So these are things that have to be represented so everybody can identify with their problem, re-identify the terminology used. And that is not the CCO terminology, that is not the BFO terminology, it's the MSE terminology. So, and then I think we also heard standards exist, so we reuse them. And if you look at Dean Term, it's a web page, Dean portal, something like that. People are relatively surprised how rarely they find the thing they want to do. So my boss, Mr. Medler, he's like the nanoparticle shadowy overlord. And first of all, nanoparticles are an object. It's very small. So it's basically the pulver is the object. But how is the pulver an object? And he's like spraying these particles onto something. He was looking at spraying. And spraying literally was the only thing that we do not do, and that is put a liquid between two surfaces. That was called spraying in the terminology deals. It's literally absolutely not a spraying. My boss does. So that's a problem. So that is a visibility problem. He would not go to the Dean term portal again because nothing is there. And so we have to, again, find I think, community process where everybody finds enough benefit to contribute their vocabulary, find out that the module of elasticity for concrete is different than for metal, but somehow it's a superclass that's still elasticity, and get domains together, get the house in order. And that is not even talking about actually creating graphs and ontologies and axioms that you reason with. It's basically the groundwork to make it documented, visible. People identify and would like to participate because they see, oh, this is almost mine. This is like the tensile testing concrete is like tensile testing. No, compression testing concrete is like tensile testing metal. Almost, with a lot of differences. But you have suddenly logistical steps like you create the object, the specimen, and then you analyze it, or you create a building and you have a quality assurance for that. And so then you understand these are very similar, and you get people to talk with each other that typically beforehand just released something with a publication and then maybe even lost interest in the topic. So there can be some retention of data, some retention of lessons learned. And I think that's where we should start, actually. And then in parallel, you can find all these floating 12 other standards and find how they might connect to what the MSE really is essentially about. And so that's just my trying to convey some experience from standardization over the years. It's making people interested and keeping them in the same room. And then I think if everybody speaks the same language, we can move on to the actual problems. So, but I think we have to do some legwork, and I think visibility, again, documentation, and getting people interested, that's the most important part.
Communication.
I'm still concerned because actually I worked in some offset standardization bodies for some time and stopped working before because actually it's no fun. It's slow work. It's like creating very formal ontologies, kind of, with people not meeting very often and so on. So that is actually very slow work. And
yeah. So after this, so I think that, but we have a very established process in science. It's called the peer review process, and peer reviews are like a ton of pages, and you have like only a few hours time as a reviewer to get through them. You're punching them through, and then the document is done. So that's science, basically, like in peer review processes. But now for our terms, you could have a more continuous process of quickly peer reviewing small abstracts or definitions about terminology, have a peer review group that is way larger with a lot of less effort, collaboratively going through that.
But actually, there is a legit problem. The Dean is in Germany the certification body for those standards. And actually, only them can put together a group which actually is reviewing those things and actually does. And if we create context, which is actually machine readable standards, that is a legal problem with those certification bodies. And we have to deal and find kind of a mechanism where you can actually agree on something which is conformant or not. So, Alexandro,
Okay. Yeah, so I don't think that problem will exist anymore because all of those standardization bodies, being part of ISO, IEC, etc., have a new program to digitalize their standards, transform them into a semi-ontology. So there is the standard-specific ontology standard, and there are activities until 2030, where all of the international standardization bodies are heavily involved. They need to do this. They're heavily invested, hiring a lot of people to digitalize, to make the standards at least at some point different levels, as autonomous driving has 5 levels, so do standards. in the future, and they're just formed now at an XML level, and we're working really hard to have them at an ontology level. But I think we shouldn't focus on this. I mean, we should focus on reusing existing standards because we cannot provide that work. So much of the work, standardization work, is really heavy and it involves a lot of agreement on terminology, but that has been already done to some level, especially in our materials characterization level. So if you're not exploring something else, it's the same as in medicine. Every doctor has a set of guidelines that are very strict, very clear to be interpretable. So if we have them in material science at some level. But our problem, I guess, is documentation and communication, because there is a lot of work that is being doubled or tripled or whatever, remade or reinventing the wheel a lot of times, because communication at an international level is difficult and agreeing upon a way to go or just informing each other is also not clear. So maybe one thing we could add to this discussion is how to better extend communication, motivate each other to participate, for example, like in the RDA groups, or open our own groups towards international participation and make a common forum. There's mathsci.org or others for this collaboration and just discuss things out as we do it right now at a more international level, because these problems have been addressed before. They're an ongoing thing. I remember them from since I started my master thesis. I've been discussing the same things for 13 years and they're the same problems. Thank God material science doesn't evolve that fast like computer science, but the problems just stick. You know?
Okay.
So I'm not talking about ignoring or even trying to step on the toes of existing norms, I want to say, and standards, but these are typically very regional specific. There is no good international one. And that a lot of, so my insight into some of the industry stakeholders I'm collaborating with is that they maintain humongous Excel sheets where they try to at least have like 13 languages and have the same concept in different languages. And then you realize there are 3 in France, there's 1 in German and 2 in English. And they form an acyclic graph. And they're somehow about the same thing, but never always are exactly the same thing. Talking about object identifiers, like materials for the copper alloys. There are competing tables how to classify these alloys. And they are simply not interoperable. They have to be accepted as distinct and existing ways to identify a certain alloy, and that in all its characteristics. And so that these are things we can, of course, not ignore. But again, visibility needs to know that this is happening. So people working in a very specific domain with a set of only 2,000 words, they can do this in like Excel sheets. But this is just for them, that's just for their own interoperability with international supply chain partners. But we have to do the same work to some extent, create a top level, again, super classes, categories, whatever, and then structure the MSE terminology in that way, and to get people involved. There are actually gamification people out there that make them. That I'm not kidding. That the Bulgarian guy is 200 words ahead, and now suddenly, to amazement, that Bulgarian guy only took the easy to translate words, so he was speeding up in the middle, and the German guy was just doing them one by one. So statistically, the other one is now slower, and he wins. And so that is not a joke. This is about 2,000 words. You have to do it. It's not fun. So even they hire gamification people to make it more fun to sort words and kind of align them in their meaning. And that is just, again, in just one stakeholder that I'm talking here about. And I think we need to help those efforts. I think we can actually be of value to industry bodies, to science publication quality and all that, if we get this. And I can only reinforce Alessandro here, this communication started, and have a place where this communication and the output is visible.
Actually, I would suggest to make that first of all in the IOF group for material science and engineering,
For example.
because it would be a good place to do it. I'm sorry, but actually we have to end the panel discussion at some point because we're already 5 minutes over time again. So thank you all for the speakers for participating in the panel discussion. I found it interesting, and that is only the start of discussions, I'm pretty sure. I'm happy that João Pedro Mendoza is here, and we will next hear his talk about zero defect manufacturing, the next standard for quality assurance.
Hello, everybody.
Hello.
So, Thomas, I'm not sure if if I start the presentation right now, and if I am in the right session.
You're in the right session, and I'm your host, and I introduced you already. So if you're able to share your presentation,
Sure.
if you can say something short to about yourself, that would be also nice. And then we are interested in your talk.
Okay, I will introduce. Let me just test if the presentation is okay, and if you can see it, it will be easier.
Yes, we can
There
see
it is.
it.
You should
Works.
be looking for it.
Great.
Okay, great. Okay, so I can have some words to the audience. So first of all, I'm quite grateful and thankful, of course, to Hedy and the organizing committee, but in particular to Foivus that invited me, and thank you, Thomas, for introducing me. Well, I've been listening to you a couple of minutes, and I must say to everybody, welcome to a nice problem. That is a long-term problem, and now I introduce myself. I'm a mechanical engineer. My background is not fully informatic or whatever. But suddenly I realized that, 25 years ago, someone in my department asked me, okay, we need to address these information issues that we may have in the future on manufacturing side. Suddenly, I tried to solve issues with CAD systems and how to deal with this information. Since by that time, DWG was a standard de facto way to express or a way to record information for CAD systems. And of course, STEP community started his first contributions to the area. And I must agree with, I thought it was Alessandro, or I can't remember who was saying that, oh no, and you, Thomas, that was saying, okay, this standard community are slow in time, and we have a lot of difficulties to go further and to progress. Well, Thomas, I have good news for you. We have been working in this area for 20 years and trying to contribute exactly to this community. I wrote with my colleagues on Uninova a nice paper. Is about the mentor methodology, which by that time I put that on chat. You can search for the paper that we published a couple of years ago. And the idea was exactly to, okay, we were assisting on the ontologies communities starting to contribute, and the way we see ontologies to contribute to this, let's say, Babylonia world that we are now facing. But of course, it's like this community onto commons and this side contributions that we may have, that for sure in the future we may have not a unified, but at least an interoperable world. And that was my claim by that time. And I just was invited because of these zero defects trends, zero defects manufacturing, as a quality management system and manufacturing area under the industry 4.0 technologies. So we were wondering how metrology and these zero defects manufacturing could have a step ahead. And okay, we just start the contribution. It was very interesting community that starts with a nice project, an Age 2020 project, and I can share you, or I will have the pleasure to share you quickly some contributions. That's why I have here these slides. So I go through these slides a little bit quickly, and then we have some nice chat for the questions you may have. Okay. So basically, like my challenge a couple of years ago, I challenged a nice student that was João Souza to endorse and to bring this metrology field into the first or into the first role or into the first place to see how can, at least with the metrology area, we can put further this community not only on terms of ontologies but in terms of normatives and standards as well. So these slides that you are seeing here are a little bit of the João contribution. So it was focused, of course, on metrology, because we know that at the end we need to measure something that was projected, designed. And since nowadays we have these two worlds digitally connected, and of course the digital twins or the concepts behind were very interesting. So João was trying to see how to contribute to this area and to proceed with not only the ontology itself, but how this let's say digital world could be a little bit enhanced to have some automatic procedure and that stuff. So it was very nice for me to hear your problems that you share about the roadmap, how to contribute to these areas and how to let's say prosper in the field. And okay, I will share some insights to you. So João was addressing this. It was very keen in terms of metrology, and he tries to set up and identify which kind of information is required in terms of not only record this quality and the procedures on inspection phase, but also how to connect this with the previous stages like production plans or even design areas. So I will go through quickly, and then we can understand better the slides if you want. So first of all, he looks for the data that he may require and the data that it may be shared with the measurement stage, the metrology area. And suddenly he tried to identify some variables from ERP side, some variables from cat sides, etc., etc. So he goes through these, and of course he tries to understand as well how the data will circulate among these different areas and activities, and how this will be interesting to be and harmonize the flux of data, flow of data, let's say, where we can, okay, at least at keys and at least at measurement level, deal with the variables and the and the data and the information that we deal. So he was identifying all this, and of course, suddenly he has to face the real world as well. So we assist on the right-handed lower side on the evolution of the communication systems and the protocols. Of course, we have this brand new world with IoT, IoT, and cyber physical systems, and the new design of these systems. But of course, we need to deal with the protocols on the left hand side, and to see a little bit what contribution standards and standard community may have on the upper level, and of course the low level protocols where we deal with variables and all that stuff. Well, I would say that João made a progress on this. He made a nice contribution because several questions arise to him, but he was focused on protocols, information models, that is, if he quickly identifies that we need to deal with this level of well, semantic, of course, but particularly that we need to have an information model to contribute to the area. And so this is the focus of his thesis. And of course, João Sousa is a mechanical guy like me. And suddenly we realize that we need to have examples where we can have contributed for the area. I'll go skip these details. I will show a little bit of the real world and how this was inspiring us to contribute to the area. And then I will come back a little bit back to see what we made, or how did we contribute. Okay, what we see here is is a production line of tubes, steel tubes production line. So we start with some strips, and then it goes through a nice machine, and then we have tubes. So we need to control these tubes. So we need to know if the tubes are with good quality. On the right side, you see a picture. Sorry about the size of the picture, but it was best we have. And on the left side, you saw the raw material. Okay, so João was mapping, was identifying the measurement of these tubes, not only diameter, but other properties and tolerances. And then we try to understand which variables and how can we use these kind of variables to contribute to the area, not only ontologies, but other fields like standards, etc., etc. And after this example, we have a second example, also under the same project is true. But once again, we have a nice machine that is producing. So João tried to identify all this chain where the variables and how the variables were interesting and important to monitor and to have the final okay in terms of quality. And after all, to guarantee that we produce, well, we may produce defects, but we need to trace them and to at least prevent that they arrive to the final client. And that was inspiring because, okay, this is in terms of CNC. The previous example were in terms of forming. And we have nowadays we have another student that is developing the same. Sorry about the Portuguese, but they are developing in a small company that deals with the some cutting processes and how to deal with simple variables in terms of shop floor, and how to identify not only this flow chart, the process flow of information and variables, of course, but these are inspiring examples. And of course, the students is trying to identify which values are we required from drawings, and how to deal with all these pieces of information. And since now we see some dimensions, and we see here that he spotted some tolerances and information, but suddenly he arrives to see, to understand that he also required to associate all these dimensions to ERP data and to ERP systems as well. So this is two inspiring examples, which lead to, I will go through the final part of presentation, and then you ask me if you have some doubts and which contributes. But suddenly, João realizes that we need to extend the actual ontology fields into the zero defects manufacturing field, let's say, or area. And the work and contribution of his PhD was mapping, for example, the interactions between KIF, that is the language for metrology area, and between FMEA, the traditional procedure where we identify some non-quality problems, for example. So he was contributing in this area with the small examples that I showed you. And the idea is to, okay, he planned all the framework based in IoT and cyber physical systems architecture. This is nowadays our reality. We no longer use manual processes. So we try to identify how we may contribute and where they are fundamental to contribute to this, let's say, new digital world that we have nowadays. Okay, he managed to contribute quickly to terminology in terms of zero defect manufacturing. And it was funny because I assisted to 6 months evolution of mindset of João, that was a pure mechanical guy, into a metrology world. And suddenly he realized that he requires some contribution to the standards. So in the future, we may have this zero defect manufacturing community with the right terms, and we avoid to repeat the same processes. And I think that is contributions and discussions like this one that are, so this is my final slide. I will keep my mouth shut for your questions. I can go back for some slides, but the idea that you may see is that we contribute to standards. So we try to reinvent the wheel in terms of inspection procedure. So Thomas, I will keep my mouth out. And now
thanks for the interesting talk.
Okay.
We are already chewing on the coffee break, I think, because we started 5 minutes late. But I would ask you for providing that link again. You gave us at the start of the talk, mentor methodology, because that is actually not a link in the chat. Would be nice to have that. And then I think we are open for questions. So everybody actually want to ask questions, go for it. So maybe the people are coffee hungry.
No.
I'm not, from this field. I've just been interested since we're also in materials and in this step. You mentioned the step, also the ISO 10303 step standards. How useful are they, or how far away are they from using in an implementation that uses ontologies in your field? Are they useful for what you are doing? Are they very far away? Do they need to be updated?
Okay, to the extent of my knowledge, STEP community has realized that they are, let's say, an ontology contributor since the beginning. They don't call it ontologies, but for sure they have all these relationship between variables and all the variables identified in such a way that, of course, it is strict, is not ontology based, etc. But they are willing to adopt this as a, I would say, ontology. And in fact, this KIF protocol, for example, that started from people on MMC machinery. So they start with a protocol, de facto protocol. KIF is a de facto protocol. It was born among, it was a simple and quite pragmatic protocol, and now they are bringing KIF protocol into a step branch, let's say. So they are merging their efforts. And what I can share with you and the insights I may have is that we have, let's say, it will be very interesting that we approach this standard community, because we contribute for the standard itself, and for sure it will be adopted more easily, more widely. I don't know if I answered the question, but the idea is that this step community is very aware of ontology contribution, and of course they only want some hint from our side or vice versa.
Thank you. That's very useful. Thank you.
Okay.
So, okay. Any more questions to Jean?
Well, I'd like to add a question. So, what are your experiences in actually dividing between measurement unit, measurement device, and then something that is application specific? Because these are like the problems that we need to face in materials characterization is when do we need the measurement unit ontology, when it goes into the measurement device more specific, and when is it like very specific to our measurement or characterization testing method, where you also need to say how do you apply that measurement device, where do you place it, what is the surrounding temperature and everything. So adding a lot of metadata. So I guess these are occurring problems. Maybe you've already addressed them.
Yeah, I will try. Very good question. Thank you so much, Alexandru. Let's see if I manage to explain you. Let's say the better one will be, okay, let's put it here. I think the better one will be something like this. Let's say this was the best approach for our example, that we have an IoT device on the machine side, and we need to bring to upper levels the information after the signal, after the ontology itself, and after not only the variable but temperature, vibration, etc. You see over here that is describing from the very low level IoT contribution to upper level, like graphs or like decisions that we need to have. And of course, we need all this entourage. We need to, okay, the work of João was to how this sensor on the machine make like an IoT device bring and to support or to share with the upper level the data that you want. It's exactly the question you ask is, okay, I need to identify the material, but of course I need a background well, the temperature, the description of the material, there is the whole context we need to set up. So it's not only to measure the temperature itself, but is in which degrees, in which units measurement they are, and how to context all these variables. And that was exactly the exercise of João, to see how the world will be connected after this work and this contribution. And suddenly we realize that there are no normatives. Well, in fact, there are, but they are a very high level. That was exactly here the explanation between the asset itself and the level that we have. So this is the Rami picture. For sure you know all this picture. But what João was trying to identify was how to bring this data, the data shared among these levels and share among these, let's say, the world connected itself and the product itself that he was trying to measure. So let's say, trying to answer you, Alexandro, there is a wall or context that we require. So this is a large challenge. So we need to contribute to some sort. So let's say, if you contribute on terms of material characterization, for example, you define some standards. And I was wondering that the community must be aware where do we need contribute. For example, Auto Commons is a nice place, so we know which guys are developing which part, and then we can have a big community.
Okay.
Okay,
Yeah.
I don't extend my answer.
Thank you. I really the people will be disappointed if they cannot drink some coffee, right? So,
Thomas,
so
sorry about
thank
that.
thank
We
you
make a
very
coffee.
much for your presentation and answering those detailed questions. And also, yeah, I really hope we can discuss it any further, maybe on the comments or in the IOF workgroup Material Science and Engineering. That would be nice. So all have a nice coffee break. I think we are back at 16 o'clock, right?
Okay.
Thanks again, Jao.
Well, thanks so much, Thomas.
I'll end the session and we'll see each other in section part 4.
Okay. I'm not sure if I can join. Actually, I was supposed to host this session till 16 o'clock, right?
Yes, there is a section. There's a session part 4.
Okay. Yeah, great. Thank you. See you.
See you.